ESE Electronics. Today's class we are going to get familiarized with the concept of radar systems. So this is a very highly requested video, and this video will be useful if you're preparing for ISRO scientist, technical assistant for the post of HSFC location, or for SDSC, that is the Saman Space Center location, or for any electronic related subject preparation. Okay, so what is actually a radar systems? Radar means a radio detection and a ranging. Means it is going to detect the radio signal and it is going to produce a range value as an output. So that is the main or the basic function of a radar. I'll tell you how a radar works. Let this be your radar, and this is a target which the radar wants to detect. Okay, so there is a radar, and this radar is sending some radio wave, or we call it as a pulse. Okay, so some radio waves is being transmitted from the radar. Now this wave will go and hit on this target, and the wave will get reflected back. Okay, so this is happening, and this radar will then detect this echo. So this wave reflected back is called an echo. So this echo is being detected by the radar, and with the help of this time of sending and receiving the echo, it will try to calculate the range of the target. Range means the distance between this radar and the target is called range. So if you have studied about the radar concept, surely you have heard this term called range. So whenever we are talking about radar, the range is the most important thing which will come into our mind. Okay, so this range means the distance of separation between the radar and the target it is going to detect. That is, this is actually the principle. If you talk, this is a principle of detecting all the airlines. We know that when this airlines or the aeroplanes are passing through our various layers, we are communicating with this aeroplane, or we are finding the location of the aircraft with the help of this radar. And also this radar is used for various purposes, for finding the distance of the thing or the target we are interested in. Okay, so this is the basic principle of working of a radar. That is, the radar will send some radio waves and it will detect the radio waves reflected back. So if you have understood this concept, then if somebody asks you what is the principle of working of a radar, then it is the sound wave reflection. Okay, so this question can also come in exams. So what is the principle of working of a radar? It is nothing but sound wave reflection. That is, we know that when we enter a room which is giving an echo, and if we speak something, we'll hear back the echo, right? So this is the principle of your radar. That is, the radar is sending some wave, it is receiving the reflected wave or the echo, and it is going to use this data for analyzing or finding the target's distance or range. Okay, I hope the concept is clear. Now, we have talked about the radar basics. Now, I have also introduced you about the range or the distance between the radar and the target, right? Now, the equation to find the range of the radar is given by R max, which is the maximum range, is equal to PT into G into sigma into AE by 4 pi square into S minimum, the whole raised to 1 by 4. So this is actually a derived equation. If you are going behind the derivation, there is a little lengthy process. We are not going to go into the derivation at all. Just study this range equation. That is the R max or maximum range equation. So this is the radar range equation. Now let us see what are the terms in the equation. PT is the transmitted power. G is the gain of the transmitter antenna. Sigma is the radar cross section of the target. Now this is a new term, maybe. Sigma means actually, so if we are going to detect some target, then the target should be detectable, right? that is the size of the target, the material of the target should be reflecting that wave. So this sigma is actually the factor which decides whether the target is detectable. Okay, so sigma is called the normalized radar cross section of target. Okay, so that is sigma. Now A is the effective antenna aperture of your receiver. Then by 4 pi square into S minimum is the power of the minimum. There is a minimum power of the detectable signal. Okay, there is a minimum power of your signal which can be detected, or there is a S minimum. Now this gain of the transmitter antenna G can be in turn represented or expressed in terms of the antenna aperture and the wavelength. G is equal to 4 pi into AE by lambda square, where A is the antenna aperture and lambda is the wavelength. Now we know that lambda is equal to C by F, where C is the speed of light and F is the frequency of operation. So these are the terms in the radar range equation. Now let us do some problems connected with this, and while discussing each problem, I'll try to introduce you what are the concepts associated in each problem. Okay, so let us see what is the first question. Calculate the maximum range of the radar for PT equal to 250 kilowatts, G is equal to 4000, AE is equal to 4 meters square, sigma equal to 25 meters square, S minimum is equal to 10 raised to minus 12 watts. Okay, so these are the terms and all the terms are given in this equation. So directly we can substitute in the radar range equation and find the value of range. So I'm writing the general equation. R max is equal to PT into G into sigma into AE by 4 pi square into S minimum, the whole raised to 1 by 4. Now the value of PT is 250 kilowatts, so into 10 raised to 3 into G is 4000 into AE is 4 meters square, so 4 into sigma is 25. Okay, so all the terms on the numerator is substituted. Now the value of S minimum is 10 raised to minus 12. So 4 pi the whole square into S minimum is 10 raised to minus 12. Okay, so the whole raised to 1 by 4. Now if you calculate this is very simple to solve. Okay, so the value obtaining will be equal to 158 kilowatt. Sorry, kilometer. The range is in meter, mostly in kilometers. So this is a range, so it is a distance. So 158 kilometers is the value of the range or the R max obtained. So the next question is calculate the maximum range of radar, where PT is equal to 400 kilowatt, A equal to 5 meters square, sigma equal to 30 meters square, and S minimum is equal to 10 raised to minus 10 watt, and frequency is equal to 10 gigahertz. Now in this equation we are not given the value of gain, and I have already explained that the value of gain G is equal to 4 pi into antenna aperture AE by lambda square. Now in the radar range equation we can substitute this value and we can reduce the equation. Now before going into the question, let us try to reduce the equation of radar or try to modify the radar equation in terms of the wavelength. Okay, because we know that wavelength lambda equal to C by F, because in this question we have given the value of F and we know that C is equal to the speed of light, which is equal to 3 into 10 raised to 8 meter per second. Okay, first let us try to modify the radar range equation. So equation is R max equal to PT into sigma into AE into, now the value of G is substituted as 4 pi into AE by lambda square. So 4 pi AE by lambda square. In the denominator there is 4 pi square into S minimum. Okay, So this much of terms are there. Now whole raised to 1 by 4 is also there. Okay, so there is a 4 pi and 4 pi. You can cancel it. There is a AE and AE. So A and AE will get AE square. Now, is there any other term to cancel? No. So the equation of R max in terms of the wavelength lambda is R max, I am writing it here again, PT into sigma into AE square by 4 pi into lambda square into S minimum, the whole raised to 1 by 4. This is the equation. Now in this question, we have given the frequency, and also we know that this lambda square is equal to, we can substitute it as C by F. So C by F the whole square. C by F the whole square into S minimum. So now all the terms are known in this equation. I'll remove this equation and we can directly substitute and find the value of the range. Okay. Now removing this, I'll write the F here. F is equal to 10 gigahertz. Okay. So what is the value of PT? So R max equal to, PT is equal to 400 into 10 raised to 3 into sigma is 30 into AE is 5 meter square. So 5 whole square by 4 into pi into C by F, the whole square is, C is 3 into 10 raised to 8 by whole square by F is 10 gigahertz. So 10 into 10 raised to 9. Now these two terms, the whole square into S minimum is 10 raised to minus 10. Okay. There is a whole raised to 1 by 4 also. I'll write it. The whole raised to 1 by 4 is your equation. Okay. You see the 3 into 10 raised to 8 by 10 into 10 raised to 9. So you can cancel this 10 raised to 8 and here is a 100. So it is 3 by 100. So 0.03, right? 0.03 square. This is your equation, and if you substitute the values, or sorry, if you calculate the equation or this term, you will get the answer as 128 kilometer is the maximum range of the radar. Okay, so this is the value of your range. Now in this question, they have not given the value of your gain, but instead they have given the frequency. So the answer for your maximum range is 128 kilometers. Okay, so this is another type of question in which you are not given the gain, but instead you are given the frequency of operation. So you know the equation for gain, which is equal to 4 pi AE by lambda square, in which you have to substitute lambda as C by F, where F is the frequency, and hence you can find the value of the range. Okay, so this is another type of questions. So let us see the next type of problems in radar systems. A certain radar has PRF of 1250 pulses per second. Okay, what is the maximum unambiguous range? So before going into the question, before answering the question, what is PRF? PRF is pulse, repetition, frequency. That is, pulse repetition frequency is 1250 pulses per second. That is the pulse repetition frequency. Now, in the question they have asked what is the maximum unambiguous range. So, what is this ambiguity? What is this unambiguous range? Okay, let us see that first. There is a radar. There is a target. Let us assume that the radar is sending a signal. Okay. Now, in normal condition, what is the principle of operation? The radar first sends a signal, then it is waiting for the echo from the target. That is, the wave will hit the target and it will send back a echo, right? So that is a normal case. But what happens if the radar is sending the next signal before receiving the echo? That is, the radar has not received the echo of the first pulse. Before that, it is going to send the next signal. So if now at this situation, if an echo is received, will the radar be able to figure out whether it is from the whether it is the echo of the first pulse or the second pulse? No. So there is some ambiguity or there is some confusion, right? So that is the ambiguity created in this case or in this situation. Now they are asking the maximum unambiguous range means the location of this target, the range or the location of this target to avoid ambiguity, or the location of the target so that the radar should be able to confirm that the echo coming is from the very recent transmitted pulse. Or just think in mind that in order to avoid ambiguity of such a situation, what is the maximum possible range? That is called maximum unambiguous range. Okay, I hope the concept is clear. Now I am going to tell you the equation to find the maximum unambiguous range. R unambiguous is equal to C by 2FB or 2 PRF, pulse repetition frequency, where C is the speed of light and PRF is the pulse repetition frequency. So this is the maximum range possible. Okay, so where C is 3 into 10 raised to 8 by 2 into PRF is 1250. So for this sum is equal to 120 kilometers. Okay, so the maximum unambiguous range possible is 120 kilometers. I hope the concept of unambiguity and pulse repetition frequency and the ambiguity created is clear to you. And I hope this equation is also now familiar. Okay, so let us see the next type of problem. Okay, a shipboard radar has 0.9 microseconds transmitted pulse width. Okay, two small boats in the same direction separated by 150 meter. Will radar detect them as separate? So there should be some time to first understand the question and the concept. Okay, I'll tell you what is the question. So there is a ship. There is a radar in this ship. Okay, so this ship is traveling in water and there are two boats. Okay, these are the two boats. They are traveling in the same direction and they are separated by a distance of 150 meter. Now the question is, will this radar be able to detect them as separate object or single object? Now how this distance of separation or finding the objects as separate, how the concept is made as clear. So in case of your microscope also, how the microscope is able to detect, or microscope or any device, how it is able to detect two objects as separate. What is that factor which decides whether this lens or this microscope is able to figure out whether it is separate or single? The factor is called resolution. Okay, so resolution is the term which decides whether this radar is able to figure out these two boards as separate or not. Okay, so that is the radar resolution or radar range resolution. Okay, so if the radar's resolution is high enough to find these objects as separate, then it will detect. Otherwise, it will be only considered as a single object. Now, another important thing to consider here is that these two objects should be in line of sight. That is, these should be in single line, roughly you can say. That is, they should be in line of sight. Okay. Now, what is the equation to find the radar resolution? Radar resolution, I'm going to remove this. Okay. So, the radar resolution, say, okay, resolution I'll call it. resolution is given by C into tau by 2, where tau is the pulse width of the radar. Okay, so let us see. C is 3 into 10 raised to 8 into tau is 0.9 into microseconds means 10 raised to minus 6 by 2. Okay. So 10 raised to 10 raised to 8 and minus 6 will be 10 raised to 2. Now 100 by 2 is 50. 50 into 3 is 150. 150 into 0.9 is, or 15 into 9. This is equal to 15 into 9. 9 5s are 35, 3. Sorry, 9 5s are 45. It is 135. Okay, it is 135 meter. 15 into 9 is 135 meter. Okay, this is the resolution of your radar. Now, this indicates that if the objects are at least 135 meters apart, then the radar will be able to see it as separate. Here, it is given that the boats are separated by 150 meters. So, will the radar be able to detect it as separate? Yes. If it is less than 135, then it won't be detecting it as separate. That is, then there is no differentiation between two objects. It will be detected as a single object. Okay, I hope this is clear. Okay, let us assume that it is 130 meter. So then the boats are not seen as separate. Only a single boat or a single target is detected. But in the question they have given the distance of separation as 150. So the radar will be able to detect. Okay, so if such a question is being asked, you just need to remember this equation, C into tau by 2, where C is the speed of light, tau is the pulse width of the radar, and by 2. Okay, I hope this is clear. So these are some questions or the type of questions that can come in the radar systems. So if you want more questions, please do comment in the comment section below. I'll be doing more videos on radar systems. Okay, so I hope this video will be useful for your preparation. I hope you have get familiarized with these concepts which I have discussed in each question. Okay, so if this video was useful, please do give it a thumbs up and also share this video with all your friends who are preparing for any of the competitive exam related to electronics. And if you want more videos, please do subscribe to the channel, and if you want more videos on radar systems, please do mention in the comment section. Okay, so that's it. Thanks for watching and keep on watching.